Hi everyone! These tutorials are meant to be short and sweet, focused on a single thing. Today we're looking at how to make a scrolling pixel material. Let's dive right in. Here's what we're trying to achieve. Something that looks a bit like a pharmacy sign or old scrolling banners. Basically, some text rendered using pixels of a single color and scrolling. Here are the basic steps we're going to take to achieve this. Generate white squares on a black background. These will be our pixels. Multiply a black and white texture with our squares. This will render the texture as pixels. Use a panner to move the texture around. And finally, multiply everything by the color we want our sign to have. First things first, let's generate a grid of white squares on a black background. Here, the reasoning is as follows. Texture coordinates go from 0 to 1 on the x and y, or u and v, axis. If we only keep values that are between, say, 0.2 and 0.8 on each axis, then we'll have an outer square and an inner square. Then we can say that one is white and the other is black. Now that's good, but we don't want just one square. What if we multiplied the coordinates? Let's say by 100. Now our coordinates go from 0 to 100 on each axis instead of 0 to 1. If we keep our previous comparison, we will have one small white square in the top left corner. How do we get 100 squares? Fmod, silly. If you're not aware of what fmod does, it's the modulo operator, also just called mod, when operating on integers. It returns the remainder of the division of its two inputs. So if you do 9 mod 4, you get 1, because 9 equals 2 times 4 plus 1. What's more interesting to us is that, for example, 1.3 mod 1 is 0.3, so we can use the modulo operation to generate values from 0 to 1 as our coordinates go from 0 to 100. By combining these three things, we get our grid of pixels, and we can vary their size by changing our resolution parameter. Now we have areas of all white, 1 on each channel, and areas of all black, 0 on each channel. If we multiply anything with that, all areas where there's black will become black, since 0 multiplied by anything is 0, and the areas that are white will become whatever color we multiply with, since 1 times whatever is whatever. So let's get a black and white texture of some text. Now we multiply it with our pixels and the text comes out pixelized. Awesome! Finally, we'd like for our text to scroll from right to left. There's a neat little node to do just that, the panner. What the panner node does is that it generates texture coordinates that are changing over time at a certain speed. This allows us to move the texture over time, which is basically what we want. So let's plug that into our texture coordinates and check out how it looks. It does what we want. Cool. Our text looks a bit stretched, but that's because it's rendered on a square, whereas our texture is rectangular. Finally, we'd like our pixels to have a certain color. At this point, you should be screaming at your screen, "Multiply, stupid!" and you'd be right. So let's choose a nice color and multiply it with our pixelated texture. There it is! We have what we set out to make initially, but one thing would make it look more realistic if it were emitting light instead of being subject to the level lighting. So let's change the shading model of the material to unlit and plug our color output to the emissive pin. Let's put it on a mesh in our world to check it out. Oh no, it looks like crap! That's because it's stretched on one axis. A simple way to fix this is to multiply the UV coordinates of the pixel grid by different values for u and v. Just add a vector parameter node instead of a constant for the multiplier, and let's do 500 on x and 100 on y. You might have to try different values for x and y until the pixels look square when the material is applied to your mesh. Yeah, that looks much better. One last thing. This isn't exactly similar to what an actual pixel display would look like, since some pixels are only half lit, but I feel like it's a nice enough approximation for now. That's it for today. I hope you learned something without wasting your time having to skip through 10 minutes of intro and unrelated stuff. I'll leave a link to the material in the description if you need to look at it in detail. Leave a comment if you have any question, and of course, like and subscribe. Till next time!